5, these will be relationships within triangles, not necessarily between congruent triangles. It just depends on what we're looking at. But we're going to look at stuff that happens inside the triangles themselves. All right, so the first definition, a midsegment. This is a segment connecting the midpoints of two sides of a triangle. Pretty self-explanatory. It's in the name even. Mid being midpoint, segments being a segment that connects them. All right, the theorem that goes with this. If you have this segment LN that is a midsegment, so it joins the midpoints of two sides of a triangle. So that means these are congruent and those are congruent. Then that segment is parallel to the third side and it's half the length. So LN is half of AC in this picture. Okay, parallel and half the length of the third side. Alright, so in this picture it says H, J, and K are midpoints. So that means all these segments in the middle are all midsegments. We need to find HJ and JK and FG. So let's start with HJ. We'll make our list over here. Alright, HJ is right here. So that is parallel to EG, so it would be half of EG. So it would be 50. Alright, let's look at JK. JK is parallel to EF, so it would be half of EF, so it would be 30. And then FG is this big long guy, and it's parallel to HK. So HK is half of FG, so FG has to be 80 in order for 40 to be half of it. Okay? Alright, AB is 10, CD is 18. We want to find EB and BC and AC. Alright, so EB is parallel to DC, or CD as they named it, so it would be half of that, so it would be 9. BC has the same markings as AB, so it would have to be 10. And then AC is the entire segment, so that would have to be 20 because it's 10 plus 10. Alright, in this triangle it says A, B, and C are midpoints. Name pairs of parallel segments. So let's start with AB because it's in the middle. AB is parallel to DF. We can kind of look at them and tell. AC is parallel to EF, and the other one would be BC is parallel to DE. You can do it just by inspection, knowing that those are midpoints, so that makes those all midsegments, so they follow the theorem. Alright, we want the measure of angle VUZ. So VUZ is right here. I want that angle right there. And it says to justify your answer. So, let's start in. You see all these markings on the triangle? That means U has to be a midpoint, and that means V has to be a midpoint because it has equal segments on both sides. So then this is a midsegment parallel to this. So then this angle is corresponding to this angle. So the measure of angle VUZ is 65 degrees. To justify it, it would be UV is a midsegment, therefore is parallel to XY. That makes angle X and angle VUZ corresponding angles. Alright, so let's say there's a bridge, and we'll make a little lake here. It's a bridge over a lake. Okay? There's the lake. Alright, it says CD is a new bridge being built over the lake, and they want the length of the bridge. So we look at this, we say C is a midpoint because 963 is the same on both sides, and D is a midpoint because both sides are the same. So then CD has to be half of this other side, so half of 2640 would be 1,320 feet. But then they want to know How long is the bridge in miles? Well, we know that there is 5,280 feet in 1 mile. That's a good conversion. So we would take 1320 divided by 5,280, and we get a quarter of a mile. Okay, just a fun little conversion. We're going to do more of those second semester.